So in the case of the elevation oblique, what happens is that what we call the principal face, or the face we are interested in your case, section through the shelter, it is sort of stuck onto the picture plane. And I'll show you next that how we are going to project back the axonometric drawing from this in a 45-degree angle. So here you could see that I find my 45-degree angle, and this is going to help me to actually draw up the other sides of this shape. All I got to be careful with, that everything I'm drawing are being parallel to each other, and in a second I draw you in the principal XYZ axis, so you could see that in this view, how does that change? So you could see that all the sides of my shapes are running parallel to this 45 angle degree, and they all running parallel. Now you could see that I drawn in how in this type of axonometric drawing the three principals axes had changed. So we're talking about the X direction, we're talking about the Z direction, and we also have our Y axis here. So all the various sides and various points in this shape, when I'm drawing it, they got to run parallel with these. So if you're not 100% sure how to start straight with the shelters, what I recommend that you just really simply set up this shape what I had set up as a starting point. You do like this quick exercise, and then you go into the shelter and draw that. Next, the shelter is coming up. Right, so we are back. We're going to start drawing the elevation oblique of our shelter. But first I wanted to start by sort of summarizing what you guys are going to need to be able to do that. I'll just put here really basic things. So you're going to need a rubber, pencils. You can use a totally ordinary pencil. That means you're going to have to sharpen it a lot more. This is too blunt. But it's really handy if you have a retractable drafting pencil. This one here, it's a 0.5, and it has got a hard nib end in there. This one on the left, I quite like because it has got a soft touch, a soft nib in it, and sometimes when I want to make some of my lines more prominent, I use that. You also, it's quite handy to have a compass. You don't need to. Sometimes you're going to find that you're going to need to measure out 45 degree. So whatever works for you, whatever you have at your hands. I'm using this because I don't have a protractor. Also, it's handy to have tracing paper, but as I said in the previous session, you don't have to work onto tracing paper. You can just have your drawing ready and work into that. Also, you're going to need different kinds of rulers. I have a straight edge here. You're also going to need different triangles. I have an adjustable set square here, but this is sometimes too clunky, and as I'm filming, it just really doesn't fit into my frame, and it's too big. So, because I couldn't find any of my smaller ones, I just made one up out of card. Okay. Additionally, you're going to need a section drawing of your shelter through your shelter, which is here. I printed mine out, but you can just very well draw it by hand. The next step is going to be that we are working into this. So again, you can start working into straight away onto your printout or your drawing. I am going to use tracing paper. One more thing, additionally, please have your measurements ready, because when we are constructing the three-dimensional heights into the drawing, in order to make it to scale, you're going to have to scale your measurements. I started off by actually doing this tutorial on a 1:20 version of the shelter, because you guys could potentially see it better, but it just wouldn't fit into the frame on my film, so I scaled down. This is a 1:50 version of the shelter, and please be mindful that all the measurements you are putting into this, all the heights, again have to be recalculated if you have them in on the scale to 1:50. I've fixed all my drawings down, the tracing paper on the top of my original section drawing, so I am all ready to go. You can decide to actually fix down all four corners, but in this case I decided to keep one flexible and up on my tracing paper so I can keep lifting it up and you guys could see how my drawing is forming away from the underlay, the section underlay. I am just elongating my ground line. I am going to use my compass to find my 45-degree angle, because I happen to have no protector in my house, unfortunately. So I am just halving a 90-degree angle here. So it's just there, the cross point between the two lines. And if you remember back our drawing, our initial sort of like simplified explanation of our setup, what you're seeing here is this is becoming your x-axis, this is our y-axis, and your z-axis, which is upright, it's here. Okay, and the way to set it up, that you align the section line with the picture plane, and this was 90-degree, and here I found my 45-degree angle there. Okay, so as you could see, I had drawn out my section cut and I already set up my 45-degree angle here. So next I'm going to start to construct the shelter in an elevation oblique. You're going to see in a moment as I'm drawing that I'm using this line here, the x-axis in our case, to project everything from my back wall of the shelter on this. So this line is going to start forming the back wall of the shelter. I know it's a little bit doubtful at the moment, but all I need to know is the measurements, and all I had to do is to find this line, and the drawing pretty quickly is going to form. Right, just a quick recap. Because I am going to draw the back wall of the shelter, what I had to decide that where am I cutting this section. So where is this section taken from? At what point of the shelter? Just for simplicity's sake, I decided to actually go through the middle, because I didn't want to faff around calculating the length from my cut point. And the next step is that I'd like to know how long is the back wall of my shelter from the section cut. And as I am going through the middle of the shelter, I know that the overall length of the shelter, when it's a structure without the roof, is 9,200 millimeter in 1-to-1 spot. The half of it would be 4,600. So I am just going to translate this 4,600 at 1:50, and I am going to measure the distance up here, and this is going to give me the back wall of my shelter. So I'll find my point here. There's the end of my shelter, so I'm just going to draw a perpendicular line there, and this is the back wall of the shelter. Initially, I'm going to pretend that the back end of my shelter, just like the front end, we know that it is curved and it's a semicircle. But initially, I'm going to pretend that it is squared off, chopped off in a squared shape, and I am going to extract the semicircle from the rectangle at the end. My next moves were finding the back wall of the shelter if it was squared off. And I started to project up the thickness of my wall, the wall thickness here. After that, I am going to move into drawing the front wall of the shelter and the next back line for the back wall on the left. It's also important to note that all these lines representing the back and the front wall of the shelter, they all running parallel to my 45-degree angle x-axis, And when I'm constructing the back end, the upright wall that is running parallel to the z-axis, and otherwise all these lines are parallel to my imaginary y-axis. You could also see that the front and the back wall are parallel each other. Along the z-axis everything is parallel with each other. So next I'm going to try to find the height of the shutter and mark up all the various heights for the window frame. And then I'm gonna, once that's done, I am going to show you how to extract out of this rectangular form the semicircle arc for the shutter. What's really good in an EXO that I don't really actually need artificially measuring anything up here, because I know that all these lines representing parts of the window frame are going to be parallel along these axes. So if I just set up my two rulers into the right angle, into the 45-degree angle, I can just draw lines from the bottom of the window ledge, then the top part of the window ledge, then I'm going to go into marking on the window frames one by one. I'm going to come to the concrete ring beam, the top of that, and eventually I am going to also get around drawing the edge of the overhang. So once the main outline of the shutter is done in an elevation oblique, just please notice that it's slightly skewed, it's slightly distorted, but that's absolutely fine with this kind of drawing. Next, what we are going to do is to focus on finding the arc, the center point of the arc. So step one, I left in my center point in the section drawing. I am going to copy this section point across here, so I want to find it on the back wall, and the best way to do it is I am aligning myself to be parallel to my x-axis, and I'm aligning myself to the end point of that, and I just found the center point of the back wall. It's there. So next what we are going to do is to find the radius, the diameter, and this circular form of the back wall. So what I had done here, you have all the wall thicknesses measured up and drawn out all around the shutter. I had done the same for the back wall, and then I looked at my measurement sheets and the dimension drawings, and then actually I read off the overarching diameter for the circle which is forming the arc of the shutter. Once you had done that, convert that to 1:50 if you're drawing your drawing to 1:50, and after that, at 1:50, I measured the end of that. So, you know, looking at it like this, I had measured this point up, which is here. Next, what I had done, I just drawn the final side for this rhomboid shape here, and I know that this circle will be sitting inside here, but we're only going to want the half of it. You can also measure up the center point for your circle, but another way to do it, if you don't want to measure it and you don't want to mistake it, a really good trick or tip here is that you connect the ends of your square in like this. This also applies for perspective drawings, and this will demarcate the center point for your circle. Obviously this is not going to be a circle, this is going to be an ellipse, and I don't want to go into showing you right now how to draw a proper ellipse. I am just going to eyeball it and freehand it, and I encourage you to give it a go. But just to reiterate, the center point for your circle is going to be here, and you can just mark it up there. Well, I just wanted you all to see this is the first attempt of my ellipse, so I had drawn it. It's not perfect, and that's why I'm wanting to show it, but I'm going to work into this. I am going to rub the unliked bits out of that. Also, I'm going to ink my drawing up, so it's not the final way it's going to stay. Important to note that I'm also going to have to repeat my oval, which is going to be the inner line for my curved wall. And that's what I am going to show and do next. So first attempt for both the lines. They are far from perfect, but the good thing is that it's a pencil and I can just rub it out if I don't like it. Right, so what we are doing next, we want to find the ends of the arc, the two ends of our curved wall. But we also know from this drawing that by drawing the ellipse, we only had drawn up to the center point of the semicircle. So I just went back to my drawings and I wanted to confirm that was the length of this tiny wall, bit of wall here, the supporting column here. So that was 310 millimeters, and the front one is 410, very interestingly. And then I convert these two measurements to 1:50. And what I had done, I kind of put them on my front and back wall as tiny dots there. And because we are working in a proline drawing, it's amazing, it's really cool, because all we got to do is to gain these uprights. Sorry guys, I'm taking everything out of my way, it's a mess here. Is to project it up like that. And I am going to show you in a sec how you can draw the thickness. I hope you're impressed with my freehand oval. It wasn't so easy to draw, to be honest. But to eliminate most of the stress, what I'm going to do next, I'm going to show you a technique how you can copy this and spare yourself the stress of keep having to redraw it. So I'm just finding the inner line for my upright wall there. And this is the edge of my front wall. Coming back to this direction, Z direction. There we go. Voila. And you just drawn your really complicated curved walls. Now to turn them into proper walls, we're gonna have to repeat the ellipse. So that's why what I'm going to show you next. How to copy this without photocopying it. So a very simple trick to copy something. I'll show you in a second. But the reason why I had decided to actually manually copy my part oval is that, as bad as it looks, I don't want to have to eyeball it again, because then it's going to be bad but in a slightly different way. And when somebody's going to read my drawing, it's going to be really obvious that the two arcs are slightly different. So if I just copy this one and copy it here on the top to finish my wall, if they are the two slightly not correct arcs, then it's less readable for somebody who's looking at your drawings. I don't know, when you were little, have you ever learned this technique to how to copy things? I love this, it's very simple. What I suggest in this time, so I'll tell you about the principle. So what happens, that you draw on a piece of paper, ideally with a soft pencil, but here I'm not drawing with a soft pencil, yeah? So you draw on the front of a piece of paper, it doesn't need to be traced, just a piece of paper, but slightly see-through maybe, actually it's good. Then you fold it upside down and you draw on the back of it, and all of a sudden you find yourself that you made a mark on a page. So So we are going to use this very same principle, and what I am suggesting that align the edge of your tracing paper, if you have a piece of trace or slightly not very good quality paper, so more see-through paper, so align it with the edge of your arc and then just really gently trace over it. And what I'm going to do next, I'm turning it over and I am just going to draw on the same line. So what we are doing next, we are going to find the top of this wall, so basically where the ring beam starts. And one way would be is that I measure up the height of this wall at 1 to 50. But because we are in a Proline drawing realm, we don't have to do that. What we do, we just align ourselves to the axes, and I could just feel my ruler moving. Sorry, I'm just aligning again. There we go. And you draw a line there, and you're also drawing a line there. And these two lines should be helping you finding the top edge of your wall. And once we have established the height of our walls, what we could do, and I show you this is the basics of exploded axonometric drawings, we could use our template, align it to the end, and just literally copy it over into the drawing. So eventually we're going to have to do this twice and copy over our ellipse twice, hence it was a good move to actually make a template of it, because once we have to copy over to the bottom part of the ring beam, but second time around we're also going to have to apply it to the top part of the ring beam. But there you go, this is very well set. So I'm just going to grab my template, align it to the initial position, and what you are going to see that I am just going to move it up and set it up where it should be sitting. One thing I haven't done, and I think it would be really wise, that this is what I'm going to do next before I copy over the arc, is that I am also going to find again the center point of my arc and the halfway point between these two walls on the back wall. And because at the moment we are copying the front of the wall, we just don't know where it ends, so it's not 100% accurate. So let me just do that first, then I'll show you straight away how I'm copying it over. So next, it's almost like an exploded axo mini tutorial within the elevation oblique tutorial. So what I had done, I marked up here at the center back point, I projected up the end points of the arcs, and so it was in this position, and all we are doing is just moving it up into the same position with the height of where your ring beam starts. Okay, so next move is that you just literally really accurately line it up, and you're just copying it over. You're just drawing over the line again. So here we go. I have drawn and constructed the top part of your curved wall. What we are going to do next is just to make the lines really visible. I am going to be quite careful here because this is the back of the shutter, this is the front of the shutter, and you know that on the back, half the way up, is the parapet wall underneath the windows. So some of these lines eventually are going to become invisible. So I'm just going to be a little bit more careful about how I'm constructing my lines. I'm also going to have to draw a line here to finish the wall to show that the back edge of that curve. But again, I'm exploiting the Proline drawing phenomena here. That, for example, to draw this, the back of the curved wall, I am just going to connect like that, and again doing the same for here, and I am going to do the same for here, and so forth. So now that I worked my lines a little bit, I am next going to draw in the columns on the front. So as I said, this is just half the shelter. That's where my section line sits. So from the column I'm cutting through, I'm just measuring up. I looked at my technical drawings, so this is my section line, and I'm looking that way. So I measure the distance between the two columns, and between the last column and the edge of the wall. Next, what I had done is, could you see here, the two inner lines are representing the columns which you are cutting through with the section. So all I had to do is to take my lines and draw parallel with them, and this little dot is showing where my column is going to sit. I got to repeat the same thing for actually the top, or I just trust myself and I'm going to eyeball it slightly because it's at 1/50, it's such a tiny scale. I'm going to just roughly guess where my column is going to sit, somewhere here in the concrete ring beam. I'm obviously going to have to give it some thickness and some weight, but that's it. Your column is done. I'm not going to go through how to draw the windows because I think at 1/50 it would be a bit crazy to go into all this detail within the tutorial and dragging it out for you guys, but it's very much the same principle that you are drawing these lines parallel with your axes. I am going to show you in a second. The next thing is going to be the roof, and obviously the roof is going to cover up a lot of working out details here, but these working out details were so important in order to understand that how to project up that curved arced end. I am not going to rub these out up until the point when I'm inking my drawing up, because these would definitely help me to understand how to draw the roof around the structure. Also, maybe some of them would help me drawing out the inking. So it is only probably at the final stage that I'm going to do that. Or what's even better, that if you decide to ink up your drawing, you can get another piece of tracing paper and do your ink drawing on the top of this. So you can always have your working out drawing intact and you're just making a copy of that. So next what we are going to do is actually to work out and draw the canopy, the roof of the structure, and we are going to do it exactly the same way how we had done it with working out the curve of the end wall of the shelter. So basically what we are doing next is we are going to pretend that this is not a circle or a semicircle, but actually it is a square. So we are going to enclose it, encase it into a square. So if I draw a really quick mini sketchy shelter drawing, there you go. There's your sheltering section, yeah. And we are going to extend these lines, and instead of doing the curvature, we are just going to pretend it's a rectangle. And what we had learned earlier about circles and squares, what we are going to do is to actually find and measure the diameter of the circle here somewhere. Then we are going to draw a parallel line with that, as this is being a parallel line drawing. Apologies, that doesn't look very parallel. And what we also learned, that to be able to find the center point of your circle, you got to draw in the diagonals in your square. There we go. So this is the center point of the outer circle, which is the overall roof for the shelter. Because again we are in parallel line drawings, what we are going to do, draw a parallel line there. So we're going to know that the semicircle, the end point of that will be here and here on this extended line. That's the x-axis. I guess the next question is, how can we find the radius on this wall? Again, remember we are in paraline drawings, so we're just going to draw a parallel line here through here. So this is the third point of our semicircle. But we also know that in an elevational oblique, a circle actually starts to distort and it becomes an ellipse. It's no longer maintaining a proper circle. So what we're going to have to do is to eyeball this in, and then we are going to project it down and draw in the thickness for the roof there. So here we go. That's what I'm going to do properly here with measurements and with the ruler, but let's do it step by step. So I had already drawn parallel with my 45° and get my parallel motion or my set square out. So that's how you're gonna get the edges of the roof. I had also extended this line or drawn this line for the roof thickness. Now I'm gonna have to get back to my measurement drawing, and I got to figure out, because I'm cutting my section is here, I'm gonna have to figure out this dimension here. So top of my head I don't know it, but it's half the shelter roof measurement we are looking for. So if you are drawing the north and south shelter, this measurement should be 5,280 millimeters. So convert this to 1:50 with a scale ruler and measure that up here somewhere on that line. So I got my point there. Again, I am working the paraline drawing advantages here, so I set up my straight edge there. So this is the end point of my roof structure, so we are here in this point. I also just remembered, and apologies for that, but I totally forgotten that actually the center point of the wall arc is exactly the same as the center point for the roof. But in my case, it is really messy there, so I would find it really difficult to measure up the height up until to the roof here. That could also help, and then find the center point like that. But I am going to ditch that. I'm just going to go with this idea of understanding the whole diameter for the circle, drawing another line, finding my center point by just joining the diagonals. So I'm going to look at the overall dimension of my circle. This was 2,740. So if we're looking at the diameter of the roof, that is 200 diameter of that, 2,740, convert it to 1:50. So you're going to need one of these. So I'll measure that up, that is there. Again, I am just going to draw a line through that by using paraline drawing, paraline motion advantage. And next I am just going to connect the two opposite corners, the diagonals, and it should align itself and sit exactly like that. Could you see that you could also measure up from the ground this dimension here onto the center point, and you should be finding the center point for your oval like that. But as mine is so messy, and I think this is also a really good skill to have on how to find center points for circles and ovals, that I just wanted to show you and draw it this way. There we go. So next what we got to do is to find, so we have the center point. I've got to draw that in again, doing palm motioning. Ooh. Please be more accurate with your lines than I am. So I know that in these 2 points, where the end of my arc for the roof will sit. So next, again, as painful as it was initially, and you guys had seen the results of my eyeballing the oval for the wall, I'm just going to do exactly the same for the roof. So it's absolutely not perfect. As you could see here, I'm not quite happy. I'm still working it out, rubbing bits of it out, but you know, practice makes perfect. What I'm going to do here, I'm going to make this line a tiny bit more visible, so you could guys see how the thickness of the roof makes the whole thing. I'm smoothing in the end of my roof. Interestingly, I find drawing this oval much easier than the little one for the wall. Maybe I'm just braver second time round. So that's it. As you could see, I had drawn in the columns. My next step will be that I ink it in, so you guys could see how it actually looks, and it's a bit more finished. I'm not drawing the windows. Please carry on. Just make the windows work. Draw them in. I also omitted to draw the window sill here because we know that on the inside does not show. It doesn't even show on the outside. It just shows through the section cut. And that's it. You're also going to see some examples on how to do an exploded exo, and that's the drawing workshop for now. Thank you. Right, next what I'm going to show you on this 1:50 version, really basic version of the shelter, is how to do something called an exploded axonometric drawing. Explodeds are really good to show spatial relationship between elements of a building. For example, if you go to a museum and you're trying to find your way around it, usually they put up a plan or a map of the museum, and that shows all the floors and the circulation routes through the spaces. Also, an exploded axon is excellent to show structural elements to a design. So for example, here I'm going to use the exploded exo principle to actually draw in the columns or extract the columns as structural elements, also to project out the windows. And as the roof, we know that the roof would sort of like cover over our view, such as it in the case of the elevation oblique, that most of the drawing is not showing because of the overhang part of the roof. We're also going to project the roof up. The best thing to do, I mean, you can do the exploded parts right onto your drawing, but you should always check out for space, because you are going to move things up and to the side. Just make sure that what you are planning on doing will fit on your page. This is going to become a little bit clearer in a second. So let me just take my tracing paper down. So I'm going to overlay it with my existing drawing, and then I'm gonna start drafting this. It's also worth noting that if you decide to go with the tracing paper principle, it's really good, because if you mess it up, you haven't messed up the entire drawing, so you can just take it off and start again. It's also good to be able to just take parts out, so it's almost like a hand-drawn Photoshop version of your drawing. So you have different layers, and you can take some parts of the layers out and keep some parts in. So for example, you can do an axonometric drawing with the existing shelter plus adding your design, and your design could be on a separate layer as part of the exploded view. But then you might also decide to use the exo drawing just to show section cuts in your orthographic drawings in a scaled down version, so then you have that as a separate drawing and you're not constantly messing with that. So I really strongly recommend that if you're doing an exploded exo, do the exploded parts on a separate sheet of paper. So what we are doing next is we are going to refer back to this principle of the 45-degree rotation. So the original columns would be sitting here, but what I'm doing, I am going to slide them sideways out of the shelters in a 45-degree. So I'm going to draw a parallel line with my imagined ground line through all the 3 columns, like this. And the column was there originally. And I am just going to decide how far do I want to project out the columns. So we are sliding it out this way. The column would be sitting in this direction, in the Z direction, and it's still going to sit in the Z direction, but we want it to be slightly out of the shelter. So I'm going to say, I don't know, I'm not measuring this, but I want the columns to be projected out about this much. So my first column is going to sit here in this point, and equal distance from the second. And same applies to the third one. And then I am just going to draw the plan view of the column here. And then in a second I am just going to project up their height into here. So I really quickly projected up the columns, but I don't yet know their heights. And if I decided not to scale up and down based on my measurement sheet, then also what I could do with my compass is actually just take this height, because this is also the height of the columns. Yeah. And I just go in the center point and I just measure it up, or the bottom point. And then I just got to finish them. Please remember that any circles in a plan oblique still stays a circle, so you don't really have to do anything with that. It's not like in the elevation oblique where any circles just become ellipses. So circles stay circles. So you guys could see that this is what the columns look like when they're sort of pulled out, projected out of the shelters. What you can then do, that this sort of working outline here, the projection line, you can use a rubber, or you can just redo it really neatly, and you can dot it in, so you can make it as a dotted line, the construction or projection line. Obviously, if you meant to do it like that, or like I'm rubbing it out, you get a much better result. So forth. So next I'm going to do the roof. I am going to take the roof and I'm going to project the roof up, so that the roof is not going to cover up the majority of my drawing. So what I am going to... So in a normal scenario where I would draw the roof right on the top of the walls of the shelter, what I would do, as we are dealing with a curved structure, I would start by enclosing it into rectangle. So the edges of these rectangles are still visible from my plan, and then in the z-axis direction I would project up to the height of the vertical walls, to the connection or the meeting point where the walls meet the roof, and then I would start drawing it in here. But as we said, that would completely cover over the existing shelters. So what I started to do here, and you could see my markings, I started to go up literally in this direction, so I can start pulling up the roof. And then I started to also measure that how high do I need to go if this is the width of the roof So if I double the height, so I'm pulling up twice as high, then the roof would still be covering my shelter. Then I went up 3 times the wall height. It doesn't matter, this distance could be anything, it was just an experiment on my behalf. And I started to see that if I pull it up quite high, if this corner is actually pulled up that way, then it will definitely not cover up any part of my shelter. You can also do it in 2 ways. You can pull it up and put it to the sideways at the same time, but I just didn't have the time to redraw, so I was trying to save my time. But you're gonna see it that it works really well like this too. So I'm just translating this rectangle, which is enclosing the semicircle here, up here, where I pulled it up. So I find the 2 corners. Next I am going to find the center point. Again, you can halve it properly, or you could just be very lazy and just say to yourself, I do it like that. Next I'm going to find the center point of the circle. It should be here somewhere. So it sits on this line, it is there. Then I am just going to measure it out. And it should roughly work. Just a tiny bit out. And next I need to find the straight parts of the shelter, because I had been coming up so high and offsetting the roof in 45 degrees. It doesn't look like I can completely finish it off, but as far as I can go, I am going to project it and I'm going to show you how to finish it. Next, what we'd like to see to find this point here is that we are just going to project that upwards. So if I had just drawn a line through there, could do the same with this line here. It is there. They should really be sitting on my y-axis, the same point where my center point is, and then I can just draw a parallel line with my center point there, through these points. And next what we would work out is the thickness of the roof. So we know that the roof is 100 mil. So we are going to project down 100 mil, repeat the semicircle, and then extend the thickness towards the back. So I had drawn down, and I'm gonna try to find 100 mil at 1 to 50 there. It's roughly there. And from that point I'm going to also draw a semicircle, especially if I lost my arc, sorry, I got to go back. And there you have it, there is a projected up roof for the shelters. You would do exactly the same on the back, but as you could see it wouldn't quite fit on the paper. It's not so much because I had budgeted my paper wrong, it's mainly because I can't fit such a size drawing into my screen. And if I downscale to 1 to 100, that would be so tiny that it would be very difficult to draw. So next I'm going to project out the window, this curved window here, and you guys could have a look at that. So as this is still the curved wall, it's very much the same game, that I got to take this shape and sort of pull it out this direction. So we're going to still look for the rectangle to encase our semicircle. So I'm just going to find the ends of that. And then I am going to project up the height of it. And then I'm going to use my compass to draw the curve. So what I have done here is, this is the structural opening, and the window frame is supposed to sit right in the middle of it. So then I divided the wall thickness, I halved that, and that line I just projected along the x-axis out. I had done the same with the other corner. Then I halved this distance so I could find the center point here. And next what I'm going to do, because I think the middle one is slightly out, I'm just going to look for my radius. So then taking from this point, I am going to establish where my window frame will sit on the bottom, and then I am going to also draw it up in the height of the windows and draw in the window panes. What's that? What's the height of the windows? So next, let's just make the vertical part of the window frame. So I'm going up in the Z direction, like that. This is the height I want. So what I had done here, in the meantime, I reconstructed the window frame. This is the height of it. I also divided it into 4 parts, because in one of the shelters there are 4 parts to the window. Next I need to divide this distance into 4, and then again repeat these circles to draw in the window panes and the window frames. So you could see that how I had also divided the height of the window frame into 4 parts, and as it is absolutely being tiny, I'm gonna have to, you've got to be mindful what scale you are drawing to and how much detail that scale is requiring. Obviously a 1 to 20 drawing is never going to be like a 1 to 5 drawing, so the level of detail you can put in, such as differentiating between the window frames and the glass panes, is going to be very little. So I think what I would do, in anybody's case, I would just use eyeballing, and when I ink it up, to actually add a little bit of depth to this. because otherwise you're just gonna really lose details. So I'm gonna draw these lines so to make them a little bit more visible for you, and then you can see the result. So this is what the final one looks like. So you have a lot of different details on a piece of tracing paper. You can kind of double check yourself that have you drawn the heights correctly, is everything else fitting, for example my roof, can I overlay it, is it accurate, or in case of my windows I can fit my window panes into the shelter. But you can also just remember your projection lines and pull them out from their places. In architecture, these construction lines, linking it back to their places, we always keep. So please keep those and use dotted lines to refer back to them.